Welcome, students, to another video lecture with Mr. Knetz. So we're moving on to 2.2. We're going to be learning about adding integers. I know many of you have already worked through this before, so it shouldn't be too much of a challenge. One thing I like to stress before I ask you to pause is that I'd like you to focus when we go through this lesson on the fact that any of these rules you're learning only apply to adding. The most common mistake that happens is when students start applying these rules to our subtraction problems, or even worse, multiplication and division. So again, you're focusing on these things we're learning only apply to addition. Go ahead and pause here and copy down what you see. Okay, welcome back. Our essential question is, when adding, how do you tell whether the sum is positive, negative, or zero? And again, we're working on adding integers. Just a reminder, integers are all whole numbers and their opposites. So going on forever into the negative world, -3, -2, -1, 0, 1, 2, 3, etc. So integers, we're learning about rules for integers. And we're also going to learn that these adding rules are going to cycle to all types of numbers. Won't matter, even if they're just integers. So let's start with adding with the same sign. First thing, please make sure that you have this heading really clear. We're going to have two different steps to show up on this note. Adding with same sign and adding with, yeah, you're right, different signs. So, do these rules apply to subtraction? No, just adding. So our first example, if the two integers are the same, add their absolute values. So I have example 2a, and if both integers are positive, the sum is positive. So 21 plus 4 are both positive integers. We're going to add their sum, and that means their sum is also positive. Notice there is not a step 1, step 2, and step 3. It is step 2a and step 2b, because you either have both integers being positive or you have both integers being negative. That's when we use these rules. Only when the integers have the same sign. So again, on example 2b, we'd start with 1. Are the two integers the same sign? We have -7 plus -10. They are the same sign, so we go to 2b. Since both integers are negative, the sum is negative. And 7 plus 10 is 17. So our answer is -17. Pretty clear, huh? Okay, let's move on. Draw a squiggly line underneath these steps, and then make sure when you write down the next slide, you're stressing this heading. This needs to be really clear, because these rules only work when the integers are different signs. So go ahead and pause here and copy down what you see. Awesome, welcome back. So notice this sequence of steps does have a step 1 and just a step 2. And again, these rules only apply to adding. So if the two integers are different signs, we subtract their absolute values. So let's look at example A. -8 and 3. Those are different signs. So we're going to have to subtract their absolute values. And we get 5. If we only read step 1, we would think the answer is 5. So let's go to step 2. Keep the sign of the integer with the larger absolute value. So which of these integers, -8 or 3, has the larger absolute value? Yeah, you're right. -8 is farther from 0. So our answer isn't 5, it's -5. Let's apply those steps to example B. Are they same signs or different signs? You're right, they are different. One is 7, one is -4. Different signs, we're going to subtract their absolute values. And then we're going to keep the sign of the larger absolute value. 7 has the larger absolute value, so our answer to that problem is 3. Those are our rules for adding with same signs, and then our rules for adding with different signs. Again, can't stress enough, these rules only work for just with adding. So I have a couple examples here. Numbers 1, 2, 3, 4, and 5. I would love it if you copied these problems down and please leave space. You know which students I'm talking to. I need you to leave space because we're going to evaluate these in class. So go ahead and pause here and copy down those 5 problems. Okay, welcome back. So again, we're going to leave these 5 problems blank because those are the problems we're going to work on in class before we move on to the assignment. Let's go to our next slide. Draw a squiggly line, and then you're going to pause and copy down what you see. So draw that squiggly line. We have a new heading, using a number line to add integers. I am going to stress that I very commonly don't use this strategy. This is a strategy they want me to teach to you, so I do. But again, I don't use it unless we're having really trouble. And that's because I want you to think, what is the limitation of using this strategy? When would this strategy not really work very well? So go ahead and pause here and copy down what you see. Okay, welcome back. So in this strategy, we're learning that we move to the positive numbers to the right, which is where positive numbers are located on a number line, the right side. And we move negative numbers to the left. And notice negative numbers are on the left side of our number line. So let's go through this example based on how they want us to do it. Technically, we're starting on the number 6. So we're going from 0 over to 6. 3, 4, 5, 6. Okay, so we got to 6. We've done this part. Now we need to add negative 9. Well, since it's a negative 9, that means we're going to be moving to the left from the number 6 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer to our problem using this strategy is negative 3. Where we end up at the end is the sum of the 2 numbers. So our answer using this strategy is negative 3. Using our other notes, we would subtract their absolute values, and then we would keep the sign of the larger absolute value. I'll let you decide which strategy seems easier for us mathematically. Let's keep on moving. So this will be our last slide of the lesson. So draw one more squiggly line underneath that number line in our example. And please write down about the additive inverse property. So I'm going to pause here and have you copy down what you see. Okay, welcome back. So the additive inverse property means when you sum any 2 numbers and its additive inverse, you'll get the number 0. Additive inverse is a synonym for what number? Or sorry, what concept? Let's add that question in there, especially considering I just said it wrong. What is a synonym for additive inverse? So what is a synonym for additive inverse? And if you're like, I don't know what that means, look at the example. 33 is the first number, and its additive inverse is negative 33. If that's not starting to clarify what a synonym for additive inverse is, let's look at the algebraic expression. What is the additive inverse of A? It's a negative A. What is a synonym for additive inverse? I'm going to tell you in class. You thought I was going to give you the answer. Now, how we're actually going to use this skill more than just adding 2 numbers that are additive inverses together is going to be an example on an equation. Our goal in this problem will be getting x all by itself. So how we're going to use this in our very near future is we're trying to get this 6 to go from the left side of our equal sign to the right. So to get the 6 to leave the left and move over to the right, we use its additive inverse. And 6 plus negative 6 is 0. So now we have 5x plus 0, which is 5x. And we'll learn that when we do something to the left of an equal sign, we have to be fair and also do it to the right. So we have started to solve this problem And again, the way we solve this problem is we use the additive inverse. So again, this property doesn't make sense by itself, but it does make sense on how we're going to apply it a lot in our future. Well, that's our 2.2 lesson today, students. If you have any questions at all, please realize, write them in the question column, because that's a great place to put your questions that you can ask later in class. I really hope you've left space on those 5 problems we had before, because if not, I'm going to ask you to erase and recopy it down. Can't wait to see you soon. Get those questions. Thanks, students.